Okay, right, hello everybody. So, I'm going to have a go at showing you how to solve some of the maths questions from today. So, we are adding mixed numbers and proper fractions. So, I will write a question out as an example for us, so you know what I am talking about. So, here you have a question here. Now, this is actually the very first question on the sheet that you were supposed to be doing today. So we'll do this one together to show you how you would go about working this out. So first thing, this here is my mixed number because I've got a whole value here and then I have got my fraction, which is part of the whole, and then I've got my proper fraction over here, so 3/4. So 1 2/3 and 3/4. Now, just to show you what this sort of looks like in picture form, we would have two diagrams drawn. Now, I'm making them into sections of 3. And I'm making them into sections of 3 because that's what my denominator over here is. So it's 3 sort of like pieces. You're splitting your whole numbers into pieces of 3. So this top box here represents 3 pieces, so all 3 are shaded because this is like my one whole. So that's my one whole. And this section here, how many do you think I would shade in here? I've got my 3, I've got my 2/3, 2 out of the 3. So I would do this, 2/3. So this picture here is what is representing this fraction. So 1 whole and 2/3. So this is my picture, okay? So if you ever find you need to do things like this and draw pictures to help you, that's really good, especially when you start getting trickier questions and larger fractions. Things like this can really help just to remind you what it is that you are working with. So we're going to have a go now, sort of calculation-wise, at solving this question. So first things first, now with this type of question, what I would always recommend is making these fractions far more friendly to work with. So this mixed number here can be a bit of a pain over here. So we're going to convert this into an improper fraction. Now if you remember, an improper fraction is when your numerator is larger than your denominator. So for example, we might have 15/5. That's an improper fraction. 15 is larger than 5. You might have 5/4. That's improper. 5 is bigger than 4. And that's what we're going to do over here. Now, if you remember, to convert this into an improper fraction, we look at the denominator, and we multiply it by our whole number. So we've got 3 times 1, which is just 3. I'll pop it up here. And then we add on whatever is left over, which is 2. And that leaves me with 5. So we've got 5/3. We keep our denominator the same. And actually, I've rubbed it out, but if you remember my diagram from just a minute ago, when it was in picture form over here, this is what I had shaded in. So this was the picture form of this fraction. But how many sections are actually coloured in right now? You've got 1, 2, 3, 4, 5 sections are shaded in. And what's my numerator there? It's 5. So pictures are great. Pictures help in so many ways. I would really highly recommend using pictures. They're a big help. So we've got our 5/3 now, and then our 3/4, that's just going to stay the same. Just going to pop him down there. So in some ways we can kind of ignore this just for now. Don't have to worry about that. So our next challenge is adding these together, but we have a problem. And our problem is the fact that these denominators are not the same. And that's the key bit of information. Your denominators have always got to be the same. So there's a couple of ways that we can go about working out what our denominator is going to be. And I hope there's some of you are sitting at home now shouting at the screen because you know what to do. So option number 1 is you can try and work out what number will appear in both of these times tables. And what I find helpful sometimes is jotting down my multiples. So I'm just going to go, I'm going up to 15, I think. So I've got my multiples of 3. I'm now going to write some of my multiples of 4 out until I spot one which appears in both of them. So as we can see here, 12 appears in both the 4 and the 3 times tables. Brilliant. But I hear some of you say, that's fine, that's great, but there's a quicker method, and there is a method that we do like using. You will also notice that 4 times 3 also gives me 12. Now, I'm not saying that you can't use this method, this is great, but we always like working in sort of the nice, easiest, lowest fractions. So just be careful, sometimes there's a lower one. It just depends on the question. I know we had some of those on Monday where it wasn't necessarily, this wasn't necessarily the lowest fraction we could use, the lowest denominator, I should say. So we're now going to go about making this match with this somehow. So what we are going to do is we're going to ask ourselves, how did I get from 3 to 12? What did I do? Well, I multiplied the 3 by 4, and that gave me 12, also because the 4's over here. And the rule is, whatever you do to the bottom, you do to the top, and vice versa. Whatever you do to the top, you would do to the bottom. So therefore, if 3 times 4 is 12, 5 times 4 is going to be 20. Bingo. So we'll leave that one, move over to this fraction over here. So I'm now going to say to myself, again, how did I get from 4 to 12? Well, I did the opposite to what I did over here. I times it by 3, which, there we go, it's over there again. 4 times 3 is 12. Whatever I do to the bottom, I do to the top. So now I'm going to do 3 times 3, which is 9. So now I've got 20 over 12 and 9 over 12. Brilliant. So my next job is going to be actually doing the calculation and adding these together. So I'm going to keep my denominator the same now. I'm going to keep 12 and 12 and 12. So we're just going to leave it as 12. We don't want to go adding these. Maybe have a little look if you get onto your Colin question in a bit. Maybe have a little look at what Colin did. Did he keep his denominators or did he do something naughty with them? And then I know that 20 plus 9 is 29. So I've now got 29 over 12, which, yep, that works. That's correct. But, we have a little rule that we have to follow when we work out these fraction questions. So you will notice over here, back at the question, that this is a mixed number. And if your question has a mixed number in it, your answer must also be in mixed number form. So yes, this answer is technically correct, but I need to now make this into a mixed number over here, just like this one. So what we're going to do is convert this back over. Now I'll do the conversion with you, but if you need further practice or reminding about conversion, I uploaded some video links or some website links on our Home Learning Hub page. So have a little look on those if you want further reminders. So what we're going to do, change our pen colour, we're going to convert this now. So we're going to ask ourselves, like a little division sort of problem this is. And again, 12 is okay to work with. Don't mind 12's too much. But if you did find it easy, sometimes people do, to jot out their multiples, absolutely fine. Whatever working out you need to do, you do it. It's whatever helps you. So I'm going to do this sum. Now remember, we've obviously got our line and our fraction. It's a division, it's a dividing technically. So we've got 29 and we've got 12. So how many 12s will go into 29 if you divided it? Well, I know that's going to give me 2, because 2 lots of 12 is 24. I know that. So I've got 2 whole lots of 12. So if I was drawing a diagram out, this would have 12 pieces made up of it. So we've got 2 whole lots. And then we have to ask ourselves, what's going to be left over? Now, first thing is that our denominator, that's going to stay the same. It's going to stay as 12. So we've now got something left over. So we know we've got 24, we've got 29. So you're subtracting those together. And I know that 29, take away 24, leaves me with 5. Therefore, my answer is going to be 2 and 5/12. And if I wanted to check that I was right and I had got this conversion correct, because there's nothing worse than doing this and getting this right, but doing that and getting that wrong, that's very frustrating. We could go back and we could check this if we wanted to. So I'm going to check. I like to make sure I'm right. We all make mistakes. We're going to go back again like we did earlier. And I'm going to say, well, I know that 12 times 2 is 24. Sorry, that's a bit small. And I know that 24 plus 5 is 29. So I know that I am right. So in the end, my final answer for this problem, I write it up here, it's going to be 2 wholes and 5/12. That's going to be my final answer. Okay.